Hello everyone, welcome to another video on solving a LeetCode problem with APL. In this video we're going to be tackling problem 1795, rearrange products table, and by the look of it, it's probably going to be an SQL type problem. Yeah, of course. So, we have a table of products that contains 4 columns, a product ID, and then 1, 2, 3 stores. And it says that each row in this table indicates the product's price in 3 different stores, fine. And if the product is not available in a store, the price will be null in that store's column. Now, okay, what we want to do is we want to rearrange the table so that instead of having 1 row per product ID, we have 1 row per combination of product and store. And we do not want to have rows pertaining stores for which the product is not available. So for example, if we have 2 products here, notice that the product ID 1 does not exist in store 2, so we get 2 rows for product 1, one for store 1 and another for store 2. So this is just what we need to do. And I think we can do this without too much trouble. So let's open up this and then let's take in some data. Now for the null, let's set the price to -1 maybe. So the data, this is going to be a 2x4 reshape of 0, 95, 100, 105, 170, -1, 80. So that's the data. Now what we want to do is we want to take all of the IDs and all of the prices. So these combinations, the first thing that comes to mind is to take the first column of data. Sorry, that's the first row. So we can take the first column and then we can do an outer product with all but the first column. So let's drop the first column of data. Now what did I do? Right, I think we would like this to be a, but this is already a vector, right? Of course, so this makes no difference. Now what I want is, no, this is fine. So what we have here is, oh, because this is not exactly what we want. So this is me combining the first product with the second row of prices, and that's not what we want. So what I want to do is I want to take the products and I want to take the prices, and now what I want to do is I want to combine this one with this, and I want to combine this one with this. So this is actually an outer product each. Almost. So what's the issue here? Now I need rows. Okay. So by splitting the prices, I get 2 vectors, or as many vectors as products, and these are the prices for the first product, these are the prices for the second one. And like I said, this only gives me the prices. So now I do an each that combines each price with each product ID with each vector of prices, and then the outer product builds these combinations. And yet again, this feels like there should be some way of laminating this, or feels like there should be a way of doing this, a better way of doing this. But right now this is what we have. Now we just need to insert the stores. So if I mix this, would I care about this? Not really. What I want is to, concatenate after the, and then mix again. And now what I want is, I want to insert the stores in here, and then I want to drop everything that is or that has a null price. Or maybe when I'm doing this each, this feels like a good place to insert the stores, is it? So I've got alpha and omega, and what I want is to have store 1, store 2, store 3 catenated to the beginning of this. Now this is going to be a vector. Yeah, I can do this. So instead of, yeah, so let me show you what I'm thinking about. Let's pause this. So omega at this point is a vector of prices, something like this. So these are the prices. Now what I'm thinking is I can table this, and now I can catenate the stores here, and then I can take the product ID, and now I get everything I need. Yeah, and then I get everything I need. So the thing I paused is over here. So this is this, and this goes on the table. Whoops, that's close, but not really. All right, so now I want to put these together and this close. And I just need to get rid of the rows where the last column is -1. So now what I'm going to do is I'm going to take all of this. So this is almost a final table. It's almost a final table, except we are going to compress it according to the locations where the last column is equal to -1. And I always get this wrong, sorry. That should be that. Wait. I'm confused. So this should give me exactly, this tells me where the problem is for some reason I'm commuting and I don't need to, and then right, so this is correct. What I want is prices different from -1. Gosh. Okay. So this feels like it should be it. But is this the correct answer? 95, 100, 105, 70, 80. Yep. Okay, so this is the correct answer. And so this is the code that we have. And is it wonderful? I don't know. There might be a better way of combining the product IDs with the prices. So these two things, there might be a better way of combining them. What way is that? So I'm not entirely sure. Let me just see if I can quickly know. How do I actually, if I can make this so let me reshape this. So I don't need the parentheses here. So let's make this a 2 by 3 by 1 cuboid, and then if I do a 0 1 catenate, I was hoping I could get zeros all the way here and ones all the way here. Well, what I can do is I can do a rank 2 thing here. Wait, I can't? Of course not, because on the left I need the scalars. Yeah, so this is another way of going about it, and then we can melt this. Sorry, we can melt this Wait, but we're still missing the stores. Yeah, but we could also add the stores with a catenate rank or something like that. Yeah, still doesn't feel the best, but it's another possible direction. So give this a think, or think about this, or give this a thought, and then well, leave a comment below, or maybe just add an alternative solution to the GitHub, and I'll check it out, and others will too. So see you soon. Bye.